Hello everybody, Root Beer here. We're going to continue on looking at the 2013 Friar. In this video we're going to be handling question number 2, so let's take a look at that right now. The outside of a field consists of two straight sides, each of length 100 meters, joined by two semicircular arcs, each of diameter 60 meters, as shown below. Straight sides here, semicircular arcs here, and we have a nice little rectangle in the middle, as shown by all these right angles. Alright, A part. Determine the perimeter of the field. Okay, well there's lots of ways to do this. The most obvious would be add up 100 meters, figure out the semicircular arc, add that, add another 100 meters in that semicircular arc. Or you could be a little clever and say, well, we've got two semicircular arcs, so combined we just need to figure out one circular arc, or the perimeter of one circle of diameter 60. Or another thing we might do if we were a little clever, we could say, well, we just need to do 100 meters plus a semicircular arc and multiply it by 2. So we have 2 copies of the 100 meters and 2 copies of the semicircular arc. So whatever way you want to approach it is fine, whatever you might have tried if you tried this question already. Many approaches, they're all equally valid. So let's just take a look at the most naive approach that we could do. Determining of the perimeter of the field just by components. So let's draw a little copy of the field right here. Oh, that's ugly. That's awful. We'll draw our rectangle at first, and then we'll draw our semicircles. So 60 meters, and then we have 100 meters. Okay. $100 meters plus the semicircular arc. Plus another 100 meters, plus another semicircular arc. Now these 100 meters, they're not that difficult to deal with, but the semicircular arcs, we need to figure out a formula for those. Well, fortunately, it's just going to be half of the circular arc, or the perimeter of a circle, circumference of a circle, with diameter 60. So 1/2 the circumference of a circle, well, that's pi times the diameter. Well, hey, we know what the diameter is. It's 60 degrees. So we have 1/2 pi, or sorry, not 60 degrees, 60 meters. Silly me. So we're going to get 30 pi meters. Okay. So the perimeter is going to be 200 meters plus 30 pi meters plus 30 pi meters. And when all is said and done, that's 200 plus 60 pi meters. Okay, I think that's all we were asked for in this question, this part of the question. Determine the perimeter of the field. Well, there we go. Okay. So B and C, and there is no D, B and C are going to be straight up written part of the portion questions. Amy and Bilius, I have no idea. Amy and Bill, I guess. Or A and B would probably be simpler and less offensive. A and B run from point C to point D. C and D marked up here. Amy runs along the perimeter of the field, Okay, so she could probably come down around here and then along the straightaway, or maybe she could go straightaway and along here. It doesn't really matter which way she goes, she's going to be going a straightaway plus a semicircular arc. And Bilius runs in a straight line from C to D. Rounded to the nearest meter, how much farther does Amy travel than Bilius? I would really love to know how to pronounce that name, so if somebody could spell it out phonetically in the comments. That's just a wonderful thing to know for future reference. So rounded to the nearest meter, how much farther does Amy travel than Bilius? Okay, well, they both take different ways around the track, and both of them are easily stated. Amy runs along the perimeter, and Bilius runs in the straight line from C to D, so both of these are completely calculable. We can just draw them up here on another copy of the field, or the track, whatever it is. So there's D down there, C is up here. Okay, so let's mark these guys in different colors. We'll make Amy green. So we'll say she goes around this way. So that's 100 meters, and we know that this is 30 pi meters from what we did before. Okay. And maybe the dark purpley or navy blue color. The heck was that? We'll have the dark purple color be Bilius. And he goes exactly across like that. So we need to figure out how far he goes. So Amy travels 100 plus 30 pi meters. 100 meters, 60 meters. So CD squared is going to be 60 squared plus 100 squared, right? Because this distance straight from C to D is exactly the hypotenuse of this right angle triangle. So we can square those and punch them in on our calculator, and we'll get 13,600. So CD is the square root of 13,600. We want to know how much further Amy travels. So we take how far she travels, and we subtract off how far Elias goes, how far he travels. So that's going to be length of CD. That's square root of 13,600. So we can start punching these in on our calculator. 100 plus 30 times pi, you get about 194.24. Normally we keep it exact, but they ask us rounded to the nearest meter. And so we subtract square root of 13,600. And we get approximately 77.6287. That's what my calculator is showing about that. So that's how much further she travels. I think we want rounded to the nearest meter. It's not 77. The 0.6 means we round up. Standard rounding rules. So we get 78 meters, and we've explained how we got it. We explained how far Emu traveled. We explained how far Phileas traveled. And subtract the two, use the calculator, and we rounded up for the to get the difference, just like they asked for. And that's all we were asked for in B part. Straight line C to D. She runs around the perimeter C to D. How much farther to the nearest meter? Okay. So C part, the last part of this question. The diagram below shows a track of constant width x meters built around the field. Okay, so here we have x meters, so this distance x meters, this is x meters, x meters, x meters, okay? So some unknown distance, everything sort of has been pushed out. The outside of the track has two straight sides, each of length 100 meters, joined by two semicircular arcs. Okay, that makes sense. The perimeter of the outside of the track is 450 meters. Determine the value of x rounded to the nearest whole number. Okay. So we don't know what x is, but we know that the whole thing bulges out by x. We still have 100 meters on either side, so it's really these semicircular arcs that have changed in terms of the overall perimeter, as say compared to this one up here. So the difference between the perimeter in A and the perimeter in C is really just about this value of x pushing out the semicircular arcs. Okay. So now we know the whole thing is 450 meters. We have 100 meters accounted for here, and each of these semicircles, either considering them together as one circular arc or separately, contributes the other 250 meters. So hopefully we can get an equation in x, and we'll be able to solve for that. So we'll draw the picture again. X meters here, X meters here. 60 meters, 60 meters, and these big semicircular arcs. I don't think I'll need the smaller arcs, but I'll add them in anyway. 100 meters. So we know that 450 meters equals the perimeter. And that's 100 meters plus the semicircular arc plus another 100 meters. So 100 meters, semicircular arc, 100 meters, semicircular arc, the big ones this time, the big semicircles. So 2 times the semicircular arc. Okay, but what's the semicircular arc? Obviously, it will be in terms of x, otherwise the x really doesn't enter into the equation, which it should. So, semicircular. So we know that that's 1/2 diameter times pi. So 1/2 because it's a semicircle, and then diameter times pi to get the circumference of that whole circle that we're having. Okay, so pi times, I should probably leave out that x because there's an x as a variable in the question. So what's the new diameter? We still have 60 meters, but on either side we have x meters. So 1/2 pi 60 plus 2x. So if we plug that into our equation, we get 250 is 2 times the circular arc, and the circular arc is 1/2, so you can see these are going to very quickly cancel each other out. Pi 60 plus 2x. So these guys cancel each other out right here, this 2 and this half. Yeah, 60 plus 2x is going to be 250 divided by pi, and we can start putting that into our calculator because once again we're going to be asked to round to the nearest meter. So we're definitely going to need to actually get approximations in here rather than just leave things in exact form. So we can, this one here is about 79.5. So if we want 2x by itself, we subtract off 60. And that's about 19.5. And if we just want x, do 250 divided by pi over minus 60 over 2. So 19.57 divided by 2, we get 9.7887. At least that's what my calculator is showing. Now we did want nearest meter, right? Let's just double check. Sometimes they want nearest tenth of a meter. No, x rounded to the nearest whole number. Okay. So 9.7, we round that up to 10. And that gives us our final answer. So that was a nice little question. I hope you enjoyed question number 2. And in the next video, we'll take a look at question number 3. So thank you all so much for joining me. And I'll see you guys next time.